My project is called Teaching Methodologies Associated with Academic Success in Statistics. For my capstone, I wanted to incorporate both my love for statistics and teaching into my research, which is why I decided to look into the teaching methodologies and strategies that have been associated with academic success in statistics. The beginning of my research started out with a literature review in order to study more in depth the teaching methods associated with this statistical learning success and what makes them so successful. So over the years, statistics education has been shifting away from traditional pedagogy and moving towards constructivist pedagogy. The traditional perspective of instruction focused on developing knowledge and skills through students absorbing information instead of constructing their own knowledge and understanding of the concepts being taught. This type of teaching style was not ideal because it led to students relying on rote memorization instead of the act of learning and engaging with the material. This is why statistics education began to move towards implementing a constructivist view of learning. This reformed constructivist perspective changes the role of teachers to that of a facilitator, where their main objective is to provide opportunities for students to construct their own knowledge through active learning activities and problem-solving tasks. This teaching style made it possible for teachers to meet the diverse needs of their students. Now, out of the 7 teaching methodologies I studied, those being cooperative learning, social interdependence theory, engaged learning, fundamental fun methods, technology, learning, focus techniques, and cognitive constructivism, I will only be going into depth for the 2 teaching methodologies that I chose to implement for 2 lessons in Professor Norak's 2 sections of DMC 106. So the first teaching method was cooperative learning. So a cooperative framework to classroom teaching required less reliance on lecturing and more concentration on engaging alternatives such as discussion activities, lab exercises, projects, and group problem solving. Cooperative learning methods enhance the way students learn statistics by deriving engagement and interest from the way students' individual goals are linked to each other, rather than relying on individual curiosity, work ethic, or the provocative nature of the curriculum, activity, or lesson plan. So the structure of a cooperative lesson plan has a positive impact on the students' learning because there are no misconceptions about the task. Students are assigned to groups and given roles depending on the task. The criteria and expectations for completing the task are laid out and stated to the students, and the teacher structures the cooperative goals for students depend on collaborating and sharing their thoughts with others in their group. Now, the outcomes of cooperative learning are that students construct their own meaning of statistical content, build upon their prior knowledge, have social interactions that enhance their learning, and are engaged in real and substantial learning tasks. Further, evidence outcomes of cooperative learning have been improved attitudes, positive growth in student achievement, improved relations among different ethnic groups, increased personal and social development, and enhanced critical thinking, conceptual understanding, and other higher order skills. The other teaching method I used was the application of technology, where technology has been one of the leading causes for the changes occurring in the content, pedagogy, and format of introductory statistics courses. So technology provides ways that allow the students to visualize, discover, and explore data that has led to new innovative methods of data analysis. To put into perspective, the GAISE College Report specifically proposes the use of technology for developing understanding of statistical concepts and analyzing data in teaching an introductory undergraduate statistics course. So the technology to be used in the classroom will be effective in assessing, analyzing, and interpreting large real data sets, automating calculations and processes, generating and modifying appropriate statistical graphics and models, performing simulations to illustrate abstract concepts, and exploring what happens if type questions. With that being said, the introduction of technology has resulted in there being less focus on computations in statistics classrooms and more focus on exploring and understanding sets of data that what can be discovered through analyzing them. The different types of technology used in the classroom are statistical software packages, educational software, spreadsheets, applets, standalone applications, graphing calculators, multimedia materials, and data repositories. So examples would be Minitab, the Data Desk, which are software packages, and also Fathom. When implementing technology into the statistics classroom, it is important to keep in mind that the various tools of software packages have different goals, and it is critical to employ different tools for varying learning goals for a lesson. So specifically, not one source of technology is going to essentially meet all the goals of the learning task. So a combination of the types of technologies available may benefit students' learning and deepen their understanding of a concept. So teachers essentially need to create a checklist for technology that will be helpful for students' learning to see which technologies will be useful for automation of calculations, data exploration, visualization of abstract concepts, and simulations. The outcomes associated with incorporating technology in the classroom have been that technology assists students' learning in multiple ways. Active construction of knowledge through students' engagement with statistics and being hands-on. Provides the opportunity to discuss and reflect on their personal findings. And increases the students' ability to self-regulate their thought processes and learning. So the introduction of technology into the statistics classroom has provided ways of engaging with the material that allows for scaffolding and tools to assist students and provides more moments of reflection, feedback, and revision during the student's learning process. This is where I moved into creating and implementing the lessons after my literature review. So cooperative learning and the application of technology were the two teaching methodologies that I chose to be incorporated into two different lesson plans for Professor Narak's two sections of DMC 106 at Goucher. I decided on these two methodologies because they are profoundly known for enhancing the way students learn in statistics by deriving engagement and interest, cultivating the construction of students' own meaning of content, enhancing critical thinking skills, conceptual understanding, and other high-order skills, and creating an innovative way for students to discover and explore data. So the lesson topic for both my lessons was the determination and understanding of p-values. The lesson based on cooperative learning was taught to the morning section of DMC 106, and the lesson based on the application of technology was taught to the afternoon section of DMC 106. To assess the effectiveness of the two lessons being taught, there was a pre and post tests that were created and administered to the students before and after the lesson taught to them. So the pre and post tests, which were the same, consisted of these 4 questions. So 1 was, if asked, could you define what a p-value is? 2, what is your comfortability level with calculating p-values? 3, if asked, how comfortable do you feel describing whether or not to reject the null hypothesis given a p-value? And 4, they were given this problem to read and find the important information in order to answer the below questions that are, what is the z-score? What is the p-value associated with the z-score? And how can you interpret that p-value? Now, the first 3 questions were given on a 5-point Likert scale, where 1 had the options of very unlikely, unlikely, somewhat likely, likely, and very likely. And then questions 2 and 3 had the options of very uncomfortable, uncomfortable, somewhat comfortable, comfortable, and very uncomfortable. For analysis, each response was given a numerical representation from 1 to 5, where the least choice was 1 and the highest choice was 5. And then since 4 had 3 parts to the question, each was marked as either right or wrong and worth a value point of 1. After implementing both lesson plans to both sections of DMC 106, their pre and post tests were used for data analysis, which began with computing the difference between the pre-test and the post-test scores for each student. The pre and post tests were analyzed separately by lesson type in order to analyze the effectiveness of cooperative learning and the application of technology. There were 8 students in the morning session and 9 students in the afternoon session. So, provided in the PowerPoint is Table 1 and Table 2, which both represent and displayed the mean, standard deviation, and standard error of the different scores for each question for the cooperative learning lesson and the technology lesson. From the data provided in tables 1 and 2 from the previous slide, I was able to conduct a t-test in order to find the p-value for each question to determine whether or not there was any significant difference in the student's scores from the pre-test to the post-test. So a right-tailed t-score was performed to calculate the p-value, which would determine the likelihood that the lessons led to an increase in scores and an increase in students' comfort level and understanding of p-values. Table 3 and Table 4 display the t-score and p-value found from the right-tailed t-test for each question. While we use a significance level of 0.05 for analysis of the p-values, Table 3 shows that all the questions from the cooperative learning lesson are significant, while Table 4 shows that all the questions but question 1 from the technology lesson are significant. The corresponding p-value for each question for the cooperative learning lesson indicates that the lesson led to an increase in all 8 student scores for each question, and the increase in scores explains that the students were more comfortable defining, calculating, and interpreting p-values. It also demonstrates that the students' overall improvement in physically working out a z-score and p-value from a given hypothesis testing. The corresponding p-values for questions 2 through 4 for the technology lesson indicates that the lesson led to an increase in the 9 student scores for those questions. The increase in scores for those questions explains that the students felt more comfortable in calculating and interpreting p-values, which is portrayed in their increase in scores for question 4, which had the students working out and calculating a p-value and interpreting its meaning. Yet Table 4 indicates that after the lesson, the students did not feel more comfortable or confident in defining what a p-value is. I believe this may be due to the fact that the students were only exposed to the definition of a p-value and what it is at the beginning of the lesson during the introduction. Other than that, the activity that incorporated the use of technology did not focus on the defining of a p-value, but rather focused more on the calculation and interpretation of p-values. From this data, it concludes that both the cooperative learning lesson and the technology lesson has a positive impact on students' understanding and comfortability with the statistical topic of p-values, and both lessons were effective in improving the student scores for questions 2 through 4, while the cooperative learning lesson also improved the scores of question 1. Therefore, the cooperative learning lesson enhanced the communication between students in groups and allowed them to have meaningful dialect and reasoning through their different roles that encouraged them to get involved and stay involved, while the technology lesson allowed students to delve a little deeper into the collection of data and interpreting it, which I believe positively affected their perspective and understanding of p-scores. After analyzing the pretest and post-test scores of the two lessons individually, we then analyzed the scores to compare the two teaching methods. For this, the Wilcoxon test was also used to compare the teaching method of cooperative learning to the application of technology. So the Wilcoxon test consisted of comparing the morning session's differences of each question to that of the afternoon session's differences for each question. Using RStudio, I conducted the Wilcoxon test, which generated the p-values for the differences in the morning session and afternoon session for each question. Displayed, Table 6 shows the p-values for the differences in the cooperative learning lesson and the technology lesson for each question from the Wilcoxon test. So the p-values given in this table suggest that there was no significant difference in students' learning from the two teaching methodologies. Since a significant difference between the two teaching methodologies is not able to be detected, either method will lead to significant improvement in the student's ability to solve p-value problems. Both methods led to the student's comfort level to calculate, interpret, and solve p-value problems to increase. After all of our analyses, we came to the final conclusion that the data reveals that new innovative teaching strategies, such as cooperative learning and the application of technology, will enhance students' conceptual understanding and lead to improvement in students' academic capabilities. And further, I believe that cooperative learning and technology are the uprising and driving forces of new innovative teaching that leaves traditional teaching methods of rote memorization in the foreshadows. Thank you so much for listening to my presentation, and here are my references.